Okay, let's get started. So this week we're talking about anonymity. Anonymity mixing and altcoins. Does anybody who here feels like they know maybe why we're talking about anonymity? Cool. I'm not going to pick on you though because you know too much. Does anybody feel like they know why we're talking about anonymity today? Is Bitcoin anonymous? Okay, that's a good thing to keep in mind. So this is our overview. We're going to start off with some basics about what we define anonymity to be, sort of how it is that Bitcoin isn't entirely anonymous, what we call that, and what we do with pseudo-anonymity, and then sort of solutions that people have come up with to combat this, because anonymity is a desirable thing. So to start off, so somebody said Bitcoin is not anonymous. Whoever said that, can you expand? Yeah.
So it's like pseudonymous, like everything is public in terms of addresses. So when someone receives funds, you know that address has the fund. If it can never be linked to any transaction, then that account is forever, never anonymous.
Yeah. Okay. And what was the major core concept behind Bitcoin? Like, was anonymity a desirable thing when they first invented Bitcoin? Getting some nods. Cool, yeah, okay. So if you recall back to the first few lectures, the cypherpunks built all of this. They came up with, David Chaum came up with DigiHash, and we have Bitcoin precisely because people were talking about privacy and how they wanted more privacy from things like centralized banks. And if Bitcoin's not anonymous, if Bitcoin is even pseudonymous, we have some problems there we need to talk about, precisely because we have layers of security that could be improved upon. So another question to think about is whether cryptocurrencies being anonymous is important to you. So does it matter to you whether or not Bitcoin, when you use Bitcoin, assuming you use Bitcoin, does it matter to you whether or not Bitcoin is anonymous? Thoughts? Anybody have comments? Okay, if Bitcoin being anonymous to you is important to you, can you raise your hand? Okay, why is it important to you? Why is it important to you?
So if it's not anonymous, I can just use fiat. It's
okay.
Another means of transaction.
That's fair, yeah. So there's something to be said for that. There's not as much difference from fiat. Does anybody else have any? Gloria, you want to say something?
Let's pretend everything is Bitcoin, everything is paid with Bitcoin. Then, let's say someone is able to see all of your transactions to this medical specialist that you see. Then they're able to see probably what kinds of medical problems you have. And that's a HIPAA violation. Obviously, it's not intended to be, but it's still revealing private healthcare data about people.
Yeah. So if we go on. One example is if McDonald's refuses to split the bill, and you say, okay, we all went out, a group of friends of us went out, and we decide, yeah, we're going to, I'll just pay for it for now. You guys can Venmo me or whatever. And then later we go to Bob's Burgers to make a purchase because my friends paid me in Bitcoin. But they don't accept my payment because my friend, little did I know, my friend is a drug dealer, and all of the money that he paid me is actually associated with drug money. Sort of transactions that have been flagged as associated with some transfer of drugs. And so because my money was associated with this drug deal, when I take it to Bob's Burgers looks at it and is like, I'm not going to take that because I'm not going, I don't want to deal with drug money, which it makes sense for a company. And so this takes us to this idea of fungibility, which is the idea that a given currency, so when I take the dollar, for instance, if I take the dollar and I go to spend it on something, usually you can't tell where that dollar's been. And you don't know, just looking at that dollar, people aren't going to look at the dollar and be like, I'm not going to take that dollar because at one point I can see in the transaction history that it has been part of a drug deal. And so the dollar is worth the same wherever you spend it, even despite whatever transactions it's been part of. But with Bitcoin, because you can tie the transaction history to that particular Bitcoin, to some people it might be worth less because people don't want to take Bitcoin that has been associated with certain things. And so this is the idea of fungibility, and this is sort of a major problem that we need to combat when we think about anonymity, precisely because without anonymity, we don't have this property of fungibility. Does this make sense? Any questions? Cool. So another example, Gloria mentioned the one with the HIPAA compliance. Another example is if I go to the coffee shop and I buy some coffee with Bitcoin, and then the same store employee who takes my transaction, who processes my transaction, can also see exactly how much Bitcoin I have because I'm exactly associated with that UTXO address. Problem being that later, when they kidnap my mom, they know exactly how much to blackmail me for because they know exactly how much Bitcoin that UTXO address I control has. So does that everybody understand how anonymity is potentially a problem that exists beyond just drug dealers or stuff like that? Questions about this example in particular? Understanding why it's problematic that my mom gets kidnapped? I love my mom. Okay. Yeah, and then coming back to the cypherpunk movement, again, the cypherpunks were really motivated by this idea of privacy, and so when Satoshi Nakamoto invented Bitcoin, the whole premise was that we had a decentralized, pseudonymous, and trustless system for transactions, which, as we're making the argument, doesn't necessarily hold true. Yeah, so part of the reason it's not super anonymous is we have this whole record-keeping system where everybody keeps a copy of the ledger, and they can go back into that ledger and exactly look up sort of every entity is the bank in this case, right? Every entity has that history, can go and look up that history precisely so that they can verify any transaction that comes through it. And so this is maybe the center of the problem with anonymity. With this, we don't have anonymity. Everybody remember this record-keeping model? Yes? Okay. So all of this is just to say that blockchains are not anonymous by default because the reason we can have this decentralized system is because everybody is on an even playing field in the amount of information that we have. And so blockchains take that central database and move it into a system where everybody has the data. And well, if everybody has the data, then it's definitely not anonymous in the sense that we'd like it to be. So all of this data is automatically more public and more transparent, which again is problematic for anonymity. Anybody have questions about the motivation here? Is that a question?
I mean, there's a good reason to make things trackable as well, right?
Good reason to make things.
Have currency that's not anonymous to avoid people who are trafficking in sex workers.
Oh, of course. Yes, of course. But if we were to tackle this problem of anonymity, there is good reason to, and that is what we're trying to motivate. Yes. Okay. So most blockchains are pseudonymous. Okay, pseudonymous. And so somebody said that earlier. Does anybody want to expand upon what blockchains being pseudonymous means? Thoughts? Okay, I will tell you. You get out of this one. So most blockchains are pseudonymous, which means that we use an identity that is not our real identity, and perhaps perhaps people can tie a history of transactions to a particular address, but they are not necessarily able to tie that address to a given person. But again, that's sort of a difficult balance, right? If I can tie all of this history to a particular address, it's not a huge jump to think I could maybe tie that address to a particular person, which is actually how they caught Ross Ulbricht, for instance, right? So there's small things like that where we want to be careful about the different layers that we draw a distinction between. Okay, so people understand the definition of pseudonymous? Okay. So the best practice in Bitcoin is to never reuse your pseudonyms. So best practice, people say, is to generate a new address every time you create a transaction. So anytime I send anybody Bitcoin, I'm also going to generate myself a new address so that it won't be associated with the same address. And so I can't link a whole history of transactions directly to my one address very easily. I want to add layers of obfuscation and make people's lives who might be trying to track me more difficult. Okay, does this make sense? The analogy is to create a new Reddit account every time you comment. which might seem over excessive, but again, if you think about the blockchain model where I can look up an address and automatically see all of your comments, and you don't want that to happen, then the next best thing would be to create a new account every time. Okay. Questions? Yeah.
How could your address be tracked to you as a person?
Yeah. So if you can, so we'll talk a little bit more about this in a bit, but a quick example is if I know that I'm just sitting in the coffee shop and I saw that I know which address is the coffee shop's address, and I saw you buy a coffee, and then I see on the blockchain network at that timestamp you this address made a transaction to the coffee shop address that I know, then I'm just sitting there and now I know what your address is, and then I can go and look it up and I can see what you've interacted with. Does that make sense? Okay.
You need to observe the
Exactly. So you would need some extra information about the person, but if you did that and you were able to tie timestamps or something like that, you might be able to infer more information, which is dangerous. Yeah. Yeah.
public key also doable?
The public key? So the public key, do you mean public key or public address? Public key. No, the public key shouldn't be viewable. Okay. Yeah.
If you generate a new address, does that mean you need to send money to that address?
So the idea is that every time I create, if I transact and I send the money back in Bitcoin, when we transact, we have a piggy bank, and if I break up the piggy bank to send little piggy banks out, I will have some change that comes back to me. So I would like to send it either to a new address or something like that, and then just switch over to the new address and then just transact from that on. So it's not entirely untraceable, but you do make whoever's tracking you lives a little bit harder. Yeah. Okay. Moving on. Yeah. So this is not possible in Ethereum because it's account-based, not UTXO-based, but it is a good thought exercise to think about how it is that you might do some sort of analysis in a parallel analysis in Ethereum's account-based system. Yeah. And basic analysis renders this switching of public addresses ineffective, because if I were just watching something actually go down, then I could take a look at whatever change address you had sent your change money to, and so even if you had switched an address, it's quite easy to see who it was that you sent it to. Okay. So linking is this idea of de-anonymizing a sort of public address to a real-world identity. So this is exactly what we just talked about. In Bitcoin, that would mean linking somebody's real-world identity to that public address. And again, that can come down to things like timestamps, can come down to things like I know somebody goes to a specific doctor, and I know this doctor only takes this one patient who pays in Bitcoin, so I can go and look up if I know the doctor's public address, I can find out who that patient was, and I can find out where the patient gets their medication, which is all very dangerous, of course. But does this idea of linking public addresses to real-world identities make sense to people? Does it scare anybody? Okay, it should, because it scares me. Anyway, so right, the technology might be anonymous or it might be pseudonymous, but in reality, even if it's anonymous or pseudonymous, the point we're making here is that you got to consider the human factors, and the human factors are people are careless, people do business in real life, and these are all sort of weak security points that even if the technology was completely anonymous, these things would still apply, so it's useful to think about. So with that being said, anonymity is sort of a scale. It's not really yes, this cryptocurrency is completely anonymous. It's great. This is the safest cryptocurrency you could use. It's difficult to say that precisely because it's the scale. You can say there's a degree of anonymity that's, for example, we'll talk about Monero later today. Monero has a higher degree of anonymity than Bitcoin does because they take certain more precautions. They shield more information, things like that. And so we can say something has a high degree of anonymity, which allows us to reasonably expect to have achieved privacy. There are various attacks that might occur, but reasonably we can expect, yes, we've tried, we've taken precautions. And so this is important because anonymous cryptocurrencies are used for all sorts of bad things, unfortunately. So drug purchases are one example. Money laundering is another example. Actually, one of the first use cases for Bitcoin, besides, or cryptocurrencies, that's really interesting, besides drugs and stuff like that, was that NGOs were moving large amounts of money across internationally, precisely because they don't have to it doesn't take as much fund. The Bitcoin network doesn't charge as much as like a bank transferring that money would. So there are like other use cases, but these are sort of some terrible ones. And so a partial solution on how we handle this sort of thing right now is these AML and KYC laws. So we can't control what happens on the blockchain necessarily because it's a decentralized protocol. What we can control are those exchanges where people interface with the blockchain. And so that's where you have anti-money laundering, which is AML, and KYC, which is know your customer. And so any exchange that you go to, or like Coinbase even, or there's some others, but they will ask for some sort of personal identification because they need to make sure that they're not helping terrorists transfer money. Precisely because if you're based in the US especially, these are things they watch out for. Okay, questions about this? Okay, yeah, so if we talk about the main takeaways here, if it's decentralized, there's more data, more of your data in that network, and more people will see your pseudonym, which can be a good thing and can be a bad thing, like we spent the last 20 minutes talking about. And then anonymity and security, more of your data is in the network, which is not always a good thing because there are de-anonymization techniques out there where people can link you to your public address and sort of tell all sorts of information about the transactions that you've made. Okay, questions about this paradoxical thing? Okay. Yeah, so we talk about how there are inherent trade-offs between these properties. If you want decentralization, you will make sort of concessions to security and scalability. If you want, I think we like to say there are only you can have 2 of the 3, something like that. Yeah, and so does anybody want to pick an example to explain why this might be? What happens if I pick decentralization and scalability? How do I lose out on security, taking what we just talked about? Anybody have any ideas? Oscar, do you? Oh, okay.
So when we talk about the scalability, we just increased the block size or increased the amount. You can kind of, it hurts the security. It can hurt the security of the network.
Yeah. That's fair. Yeah. Mm-hmm.
Yeah, I guess same idea that if you choose decentralization and scalability, then you make security lower because scalability implies faster processes, easier processes for miners, for example.
Yeah, that's definitely true. And then back to what we were saying about decentralization. If it's decentralized, there's less I have given my data out to a whole bunch of people, and so therefore, kind of by definition, I have made myself more vulnerable to attacks because more people have my data now. And so while there are more points of failure, and that's sometimes a good thing in decentralized systems, it also makes security a lot more difficult. Okay, so the discussion question for this one that I forgot to put on a slide is, what's the difference between UTXOs and accounts? So how does that affect how a blockchain is anonymous? Okay, discuss.
Does anyone have UTXOs? Directly connected to my also think about that. Really obvious thing where you can't change any town without yeah, so it kind of goes back to what we're talking about creating up so we make change that transaction. So you end up in the best practice making a new public key, a public address, and sending it to it. Whereas in an account-based system, that wouldn't actually happen. You guys easily do that because you only have one account.
It's that middle guy as the outside you have one of you don't pay for it. Assuming that neither end related is called
To a new account. So it's kind of different in terms of security because
you have an entire network.
you have two
This is the entire network basically has a vertical thing where
you only have one.
you cannot distinguish where a transaction came from, but you also can't distinguish what is distinct or who is going on.
I think there are like we're going to talk about the ways that they so the types of attacks that someone do to find out similarly to public addresses to launcher that are going to be different as far as which one's safer. I think both of those systems, if you don't have a conditional security, they have the address.
Okay.
You can do more than just
Yeah, so the way that addresses work is that it's basically you're not like taking up space for the just because the number of possible addresses is so big. You don't have to make a new address.
This is true. But it's sometimes
Then it's interesting.
it is
Okay. Let's come back and does anybody have any like pressing questions that didn't get answered that I can help answer really quickly? Okay, cool. So on to de-anonymization. There we go. Yeah, so we talked about this a little bit, just introducing it though. So if we dive a little bit deeper into how exactly this happens, the basic premise is that we can go back into the blockchain's history to reconstruct the history of like what's happened, and then from that extract information about what different addresses might be associated with. And so if you look at this graph, the goal is to link a given entity that is like a huge cluster that has like a lot of activity happening with it. We'd like to link that with a real world identity. And so when we look at a graph like this is a transaction graph, which means that I can see, for instance, like you can see the Silk Road over there. Everybody can see the Silk Road? Yeah. So like the Silk Road is like quite a large one over there. Not as large as you would expect anymore, but that being there just means that like a lot of transactions have happened with that. Over here you see Satoshi, BTC Dice, like some other games, BitPay. Yeah, so like this just means like the number of transactions that have occurred with a given like entity, with a given public address is all represented in this transaction graph. And so we'd like to do some sort of analysis on this graph to derive useful information and hopefully attribute a cluster of transactions to the same entity, even though that entity might be changing addresses or changing public addresses. Does that make sense? So we're taking on the role of somebody who's trying to like do that anonymity analysis in this part. Okay, so there are two main heuristics that we can look at. The first thing that we want to note is that in the Bitcoin network, because of the way UTXOs work, there's like we merge transaction outputs quite rarely. So because there are fees that get taken out and things like that, when I go out to eat with my friends, I'm not going to be paying in Bitcoin. And so if there is an instance where two UTXO addresses are paying to the same address, 9 times out of 10, those two like little piggy banks that are getting joined together for one transaction are coming from the same person. So the same entity is controlling it. Because think about how UTXOs work. When I make a transaction, I'm going to break open like whatever piggy banks that I have to construct, to put together like parts of the puzzle to send them like a whole dollar. I'm going to find 50 cents here and 50 cents there. Does that make sense to people? Any questions about this? Okay. So again, the basic idea here is that like 9 times out of 10, somebody making a transaction is going to control both of those addresses when they pay to a singular account. Okay, no questions? Okay. And then the second thing is this idea of change addresses. So again, whenever so for instance, if Bob spends 1 Bitcoin and sends like 0.05 Bitcoin to the coffee shop and 0.95 back to himself, anytime you see a transaction where like you've sent something and there was one recipient and then another recipient, again, 9 times out of 10, it's going to be a change address because you never, it's very rare that you make a transaction and there's no money left over that you want to send back to yourself. And so knowing these two things about the UTXO model can really inform how you look at the transaction graph and make analyses on what addresses might be clustered together. Do these two things make sense? Any questions? It's tricky. Okay. Yeah. And so in both cases, if address A was owned by Bob, we now know that address A prime is also owned by Bob. And so that would be the conclusion we could walk away with because with high probability, that's usually what's the case. Okay. Okay. Another discussion question. Oh gosh, ouch. Yeah. So maybe like turn to your neighbors, talk for like 5 minutes about this one. Has everyone read the question? I'm going to go back to the previous heuristic slide to make you guys' lives easier. Okay, a minute to read the question. Okay. Does everyone understand the question? Thumbs up if you understand the question. Okay, I'm going to go back.
These two heuristics are mainly for associating accounts on and so this was someone's account, this is a change account. So the question is can you still use these methods on an account?
If you're running somewhere second, it makes sense. Go right for it. For like case.
Something is worth like $5 and what is my and then
It's just like if you increase block size, you're going to and there's more changes to
I think it would just be no change. Just be like you have 100, and then those are sort of you don't have to make anything. You just send 5. There's no like I think in this case, like you wouldn't need to change addresses to just because
they have
on the addresses you don't make new addresses would still change. It's not necessarily that one you wouldn't be able to.
Okay, let's come back. So if we continue on, so moving on, so we're going to talk about other techniques to identify clusters. And so here are two. First being, if I really wanted to, I could go and make a transaction on Coinbase and then wait and just watch my graph and watch until like whatever transaction I made, because I know I know everything about that transaction. I'm just going to wait to see which cluster it gets merged into, and then identify, oh yes, this cluster is, I'm going to call this Coinbase. Does that premise make sense to people? Just one way to like be able to label the different clusters. If I really had no idea that like that one over there is Mt. Gox and like that one up there is Bitcoinica. Yeah, and that one up there is Bitcoinica. If I really had no idea, one way would be to transact with them and then just like watch my transaction get merged into that cluster. Questions? Okay. And then the second one is just inferring by looking at activity. So in 2013, which is when this picture is from, you can see Mt. Gox is like a huge circle. And so you know that like most of the transactions go through Mt. Gox, and so you can say with high probability this giant one over there is Mt. Gox. Does that make sense? Okay. Yeah, Satoshi Dice is also quite popular. It's a small volume of like money passing through, but it's a lot of transactions, which is why it's like a spiky ball. Okay. Yeah, and so we were talking about identifying different services. Now we're going to talk about identifying individuals. So a couple techniques you could use to try and associate a person with their public address. One would obviously be to send them Bitcoin. In order to do that, unfortunately, you do need their public address, even though everybody does like free Bitcoin. So that's one way. If you could get them to just give you their address, then you obviously know who's associated with this given public address. The second one is carelessness. So if you post on a forum where you have like an email address associated with that account, or you have a username associated with that account, and you post your Bitcoin address, that reveals at least like one link to a real world identity. You see like some places people post like with their username, and then they'll post like, you could like, did I like help answer your question really well? You can send me Bitcoin at this address. And so that sort of thing like is particularly useful for, in this case, where you're trying to tie somebody's real world identity to their Bitcoin public address. Any questions about that one? Okay. And then the third one is service providers. So there are people who are actually just on the network to garner information, and they provide a service of like trying to like figure out who, like trying to de-anonymize this by like performing various analytics on this blockchain transaction graph. Okay. Any questions about this? Okay. Okay, and then finally, the idea of taint. So we talked previously about fungibility, which again is the idea that I'd like my dollar to still be worth $1 no matter where I spend it and no matter who has touched that dollar. And we talked about how that's not necessarily true in Bitcoin, because if I can see the entire history behind one Bitcoin, and I can see that this Bitcoin was associated with some drug transaction, then some people might not be willing to take my Bitcoin, which means it's worth less. And I don't want to take it from other people as well because I can't spend it everywhere. And so taint is the idea that I can trace some percentage of my funds to an address, back to another address, back to another address. And really I have one Bitcoin, but I can look at the Bitcoin and say 95% of my Bitcoin is pure Bitcoin straight from the Genesis block, or like, but 5% of my Bitcoin is actually from a drug lord who sold a whole bunch of cocaine. And so that sort of thing, while it can be interesting, also means that it takes a lot of, like, if you consider the ones up there that are like bright red, those are like from a dirty origin, they're 100% like dirty, quote unquote, Bitcoin, then it takes a lot of clean Bitcoin to wash out and to dilute how dirty, quote unquote, a given Bitcoin is considered. Does that make sense to people? Yeah, okay, cool. And so the naive anonymization strategy here is to send all your coins to a bunch of fresh addresses, and because we originally like discussed this where we said if like my public addresses has been have been compromised, and people know that like this public address is associated with bad things, I'm just going to send all of my Bitcoin to new public addresses, and voila, problem solved. Problem being this sort of thing, where you can trace where the Bitcoin came from, precisely because we can see the transaction history, and you can see what percentage of Bitcoin came from which address. So this taint thing makes things like manual mixing very difficult. And one way taint analysis was useful is that this is actually how, so Ross Ulbricht, who you remember is the guy who was Dread Pirate Roberts, who was running the Silk Road, and his defense when he went to court was something like his huge Bitcoin stash wasn't actually obtained from drug money, which they sort of debunked precisely through this taint analysis mechanism, where they said, well, no, we traced all of your transactions, and we've seen that like they're directly correlated with this amount of drugs being transferred to this given person. And so from that, they were able to say, well, no, like 100% of your Bitcoin is actually, all of that is from a dirty origin. Okay. Any questions about taint analysis? Okay. Okay. So now we're going to talk about how we can achieve different ways to achieve anonymity, one of which is through mixing. So the basics of mixing. Does anybody have any ideas what mixing might refer to? Given that we just talked about taint and like throwing in new coins. Yes.
Like everyone who's doing a Bitcoin transaction sends it to one address, and some of them are going to legitimate purposes, and some are going to other purposes, but essentially put all these UTXOs into one and then send them out, and you can't link the origin to the recipient.
That's one way to do it. That is a protocol that exists, and we will talk about it later in the lecture, but there is more than one way to do that, and that's not quite mixing per se. Yeah. Any other ideas? That's a really good idea. I actually don't know of a protocol that does that. Unfortunately, I don't know why, but that's really good. That's not precisely exactly what mixing is, though, either. Like, actually, I think some protocols do that. I may have misunderstood what it is you said, but I'll come back to that. Okay, so this was just kind of for fun. I won't actually ask you to answer this, but suppose you're a drug lord. What's a valid way to hide your drug money? Hands up if you think it's A, you hide the money under your bed. Oh my god. Okay. B, behind the wall. C, offshore accounts. D, shell companies.
They all good ways.
They are all good ways. Some of them will get you more killed than others. Okay. Yeah, so I would, if I were a drug lord, I'd probably go with D, but I don't know. So, traditional mixing / money laundering. So to my knowledge, the way this happens is you create fake shell companies, which don't do anything, they don't have any assets, but they exist as an entity, as a company, and their purpose is purely for accounting, for tax returns, so that whenever you file your tax returns, you can explain where all of this money, you've sent all of this money away from yourself, so it's not associated with yourself. And so the idea is that over time, you're going to deposit these quote-unquote dirty funds that were obtained from illicit means into these shell corporations. And then in these shell corporations, you write them off as like deposits from people or purchases or investments and stuff like that. And so you explain away the money, and you sort of like find things to make it look real. And then this layering is the idea that like sometimes people do like shell corporations, they'll send money from shell corporations to other shell corporations, and it becomes like a nice mess of different shell corporations sending money to each other. And then integration is this final step where finally, after all of those legitimate transactions, the shell corporation will like pay out a sum, and then the criminal organization will like integrate that money back into society by buying goods or buying luxury cars or what have you. So does this basic process make sense to people? As much as it can? Okay. Yeah, and so mixing on blockchains sort of goes through the same idea, where we'd like to send it to a shell corporation, like you were saying earlier, and then like have it get mixed up there, like send it to all sorts of like fake addresses and then send it back to yourself. Okay, so formal anonymity, that was the intuition part. Now we're going to talk about how to do this formally. So you want an anonymity set. So that means that I'd like a set of pseudonyms where a given pseudonym can't be distinguished from like other pseudonyms, which means basically the premise is that of this anonymity set, I don't want any of them to be any of those addresses to have been compromised. Does that make sense? Okay, and so the main goal of mixing is to be able to send my money to this anonymity set, have it get all mixed up and clean, quote unquote, and then get sent back to me. And we want our anonymity set to be as large as possible. So if one round of mixing makes it very difficult to tell who among the n people that money originally came from, then if I have more people as part of that set, it only becomes more difficult to identify which one in that set sent the original money. Does that make sense? Yes? No? Questions? Okay. Yeah. So n squared after. So if I do one round of mixing, I am indistinguishable among n people. If I do 2 rounds of mixing, then you have an even lower probability, 1 in like n and then 1 in n again, of having picked the right person and so on. Does this basic premise make sense? Any questions? Okay. Additional things that we would like to look out for when we consider different mixing protocols is we'd like it to be trustless. So ideally, you don't have to send it to somebody that you have to trust. If there's somebody handling all of this mixing, then that's somebody that you have to trust. And furthermore, we'd like to trust that if I send my funds somewhere with the hope that they get mixed and they never get sent back to me, that's not ideal because now I'm out like 50 Bitcoin. So yeah, so we'd like to ensure that our funds don't get stolen while mixing, which is actually quite difficult to ensure. And then plausibly deniable. So if you think about who exactly is going to be the people who are sending their money to a mixer, it's really difficult to explain away, like, why were you sending money to a mixer if you have nothing to hide? So we'd like to sort of abstract that away and not have that be a problem so that just anybody could send their money to a mixer and it would be completely normal. Does that make sense? Because otherwise there's like, you've really identified all the people who have something to hide because they've all sent their money to one address. But does that make sense? Okay, cool. Any questions? Okay. So another discussion question, what are some potential problems with mixing? Would I rather be in a mixed set with 10 or 100 people? Second one being just like sort of a check to make sure that you understand what a mixed set is. Discuss with people around you.
What do you guys think mixing is? Oh, yeah. This works. Over the head. Oh, dude, this is big. Yeah. Oh, really isn't that bad. This is big on me. Nope. Oh, you can type this stuff? Oh, it is cute on me. Alright. Do you guys have any questions? Juan, you got a question? Hit me. How you doing, Juan? I'm good. Got any questions? Not yet? What do you guys think the answer is? 10 people or 100? It's a tricky question. Think about ability.
It's not a trick question.
That's what she wants you to do.
It's really not a trick question.
Anyone got it? Alright, raise your hand for 10. Alright.
Oscar. Misleading people.
Well, you guys weren't wrong. Alright. Jason, follow. Alright. No questions? No account mixing? Okay, wait. They're right there. Honestly, could use it.
Alan, can you go and see if anybody up there has questions?
Which one? That section?
Oh, yeah.
Oscar, how's your section? Sorry? How's your section? You guys got any questions up there? What's up? No? No questions? What's the answer? Oh my god. Jeez. Oh boy. 10 or 100? Oh, really? Sounds good.
Okay. What are some potential problems with mixing? Anybody come up with interesting ideas? Nobody has any thoughts? What are some problems with mixing? The basic premise. Trusting the mixer? Sure. Okay. What else?
Doesn't hide long-term trends.
Doesn't hide long-term trends. Yeah, that's true. Anything else?
It's centralized.
It's centralized. That was already said, but yes. Sorry. Anything else? So what's the basic premise behind mixing? If we think back to taint, why would if I have really tainted coins, would I send it to a mixer? Okay, how many people think if I have tainted coins, I should really send my coins to a mixer? Hands up. Okay, you're not entirely wrong, but everybody else sending their coins to the mixer is also thinking the same thing, so we're all just mixing dirty coins with each other. So what's the point of that? So if you think about this, potentially you could have like a mixer where like we're just mixing dirty coins with dirty coins, which doesn't make the coins any better. And so when they come out, they're still completely dirty. And so we haven't really provided a service there. That's a potential problem. Any other thoughts on potential problems? Yeah.
Instead of making one transaction, now you're basically making the system into 10 transactions.
So the idea behind a mix set is less that like you send your money to somebody else and they make the transaction for you. It's more I have money and I'm going to send it to this group of n people, like say 10 people, and they're just going to like this centralized mixer or this mixer protocol is going to decide we're going to break up the UTXOs and like sort of scramble it around the same way you shuffle like cards or something like that, and then send the same amount back to. And so you like do the final transactions, but it's just about like breaking up who owns what Bitcoin. Does that make sense?
Why do you still have to add more blocks per transaction?
More blocks per transaction.
You still have to make more sub-transactions to make your full transaction.
So you are adding transactions to the network. That is true, but I'm not sure what you mean by sub-transactions.
Like if you want to send your money to a mixer, that's a transaction.
Yes.
And then everybody has to mix it, so that's like n squared transactions right there.
Yeah. So
you have to send it back to you. So that's like a lot more transactions just to make like one single transaction. That's the main transaction you're trying to make.
that is true. By sending my money to a mixer, I do generate like there's going to be some sort of fees involved because there's a lot of transactions involved. That's true. That is a cost that is associated with mixing. And it's not something that like people have really solved. It's just enough of a need that people are willing to do that. And it's not like a huge problem to the point where people have been like, oh, it's breaking the system because everybody's trying to mix their coins. Okay, so we continue. So hopefully everybody came to the realization that the larger the anonymity set, the harder it is to link pseudonyms to real identities. So we would much rather go with a set of 100 rather than the set of 10. Does anybody disagree really strongly with that statement? It's okay to say so. Okay. Yeah, so there are a couple of different kinds of mixers. First, like maybe simplest is to think of a centralized mixer. So I trust a third party to do all of this like shuffling behind the scenes. Another idea is altcoin exchange mixing, decentralized mixing protocols, privacy-focused altcoins. So we'll talk about a couple of these centralized mixers. First, Altcoin exchange mixing is the idea that if I have some Bitcoin and I'd really like to get out of my dirty Bitcoin, I can transfer that Bitcoin into a different altcoin and then come back into Bitcoin, and then I'll have some new Bitcoin because somebody else now has my dirty Bitcoin. Does that make sense? Altcoin mixing? Yes. Okay. Decentralized mixing we will go over, and then privacy-focused Gloria will talk about. So let's continue. So for centralized mixers, we're going to call a third party TTP for some reason. So TTP sends hopefully unlinked coins to you after you. So Alice has a dirty input. She's going to send it to this large mixing service, a centralized mixing service, and then hopefully at some point this third party will send you back some Bitcoin, and they'll take out their cleaning fee, quote unquote. Does this general diagram make sense to people? Any questions about the diagram? Yeah.
You solve the problem where everyone's only sending their dirty coins.
Yep. Yeah, we will talk about that. There's not really a good solution for that, except offering people money. Yeah. Okay. Problems with centralized mixers, counterparty risk. So you have to trust that that third party doesn't just steal the funds and never send any of their Bitcoin back to you, because again, that's like still a third party, still centralized, not necessarily what we want on a Bitcoin network that's focused on privacy. After we've spent so much time talking about privacy, that third party, you kind of have to trust that third party that they'll never be hacked, that they're not storing your data. Every time you send them like 10 dirty Bitcoin, they're not like writing it down, oh, Jillian sent me 10 dirty Bitcoin, she's like a drug lord. Yeah, so you have to trust that, the logging risk, that's what that is. And then centralization risk, the idea that all of that data is now concentrated within one third party, which makes it one central point of failure, which again is not necessarily what we're looking for with blockchain and decentralization. Okay, so two examples of centralized mixing services are over here, Mixedcoin, Blindcoin. Might be interesting to go take a look at those two and the services that they offer. Any questions about the conclusions we came to about centralized miners and mixers? No questions? Okay. Altcoin exchange mixing, the main idea is I have one dirty Bitcoin, I'm going to put it into an exchange and get out a different altcoin, and I'm going to do that like a couple times. And then when I come back, I will have expended maybe 0.1 Bitcoin just from transaction fees, but I'll come out with some presumably clean Bitcoin. Does this make sense? Because I don't get the same Bitcoin as I did have at the beginning, and I just like exchanged mine for a different one through exchanging. Yeah. Any questions about this? Okay. And so some pros and cons to this. The adversary, it's not impossible for somebody to track what exchanges happened across different altcoins. And so you could technically, like if the government really wanted to find out who you were, it's possible. It's not completely foolproof. And then the second pro there is better plausible deniability, because people exchange currencies all the time, rather than sending my money to a mixer, which might raise some eyebrows in like a law of court, for instance. And then cons are that you rely on those exchanges, again, to keep those mappings hidden, by which that means I really hope that Mixedcoin doesn't get hacked and then suddenly everybody knows that I sent 10 Bitcoin, or like my public address sent 10 Bitcoin to this mixing service. I sent 10 Bitcoin to get exchanged into different altcoins, and then I like got my 10 Bitcoin back. Does that make sense? Okay. Counterparty risk. Exchanges are centralized, and they're like sort of the vulnerable points on a blockchain network, just like any human interfacing point with the blockchain network. And so if the exchange gets hacked, your money could get stolen, even while you're in the process of getting like all of your money exchanged. And then finally, if you are trying to transact large amounts of Bitcoin that are all quote unquote dirty, it can be quite difficult because exchanges are regulated by law to look out for that sort of thing. And so they have those KYC and AML laws that we were talking about earlier. Again, KYC is know your customer, which means that they will know who you are. And AML is anti-money laundering. So again, making sure that you're not just transferring large amounts of your money out of the country so you don't have to pay taxes and stuff. Okay, any questions about the pros and cons of altcoin mixing? Cool. So on to decentralized mixing. Yes, the idea you definitely didn't see coming. So the basic idea is to remove counterparty risk because we said all those bad things about centralized mixers and how they're bad. So we'd like to avoid fees by taking out the middleman and somehow coming out with a network of peers where I can just send my money to them and something will happen and I will get clean Bitcoin back. So does anybody have an answer for this? Well, you have to discuss about it. So what are some potential problems with decentralized mixing? What assumptions am I making? Turn to the person sitting next to you and talk about this for 3 minutes, 4 minutes.
What do you guys think?
Decentralized will happen. It's the purpose.
So you would hope that the people that you're working with don't expose you, but if they don't expose you, so let's say we are doing this. We don't tell them who do this too, and then we let them know. You think it's just California?
Because the decentralized
You should get it embellished right underneath. It says Blockchain of Berkeley and then say like marketing.
Wait, that's what
That's what you're talking about? We were talking about that in academia too.
Wait, but I screwed up because I thought it was low padding. Okay, I'm pretty sure it's too big.
Oh. I mean, you can trade it with somebody maybe?
Yeah, so we weren't rejected. I was thinking cool. Hurry up, come on. Yes or no? I want other people to learn. I don't want to take it. Oh, so where do you go? Teach me then. I want to learn. Teach me. Alright, teach me. Yes or no? 5. Yes. Alright, explain why. Explain why. So, in order to find why, they have first find that. What about you? What's your name? Judah. What do you think? Yes or no? Is it possible? Yeah, is it possible? Alright. Is there any issue if it's possible? Alright, let's go through like the problems on the centralized. Do you think people can still track you, like log it down, like if you're like sharing with like a group of people that is decentralized, right? And you put in like all your dirty Bitcoins. Do you think they can still know?
They don't know. I think it would be hard to know the guy that makes sense would like all the other people. So they don't set up it's actually the person who bought the drug
Okay. Sounds good.
But I think it's I don't know. I'm not I just want to say like everything is possible because it's like, you know, who knows?
Exactly. The answer is always yes. Besides 42, the answer is always 42.
The answer is always it's possible for someone else does not need to figure out. What about coins?
It's possible for you to figure out too. Just the answer should be like, yes, I can figure it out. Maybe one day. Give me 2 years. Okay. And the name Satoshi.
Yes.
I see. Yeah, can you put mixing that which type? Decentralized, centralized. This.
Like instead of getting a ton of
Okay. Say we want to be a mixing group. Okay, I'm gonna give you some. Taunt's gonna give you some.
Okay, let's bring it back. Okay. So what were some assumptions that we were making with a decentralized mixer? What are some assumptions we make with a decentralized mixer, guys? Come back. Okay. Does anybody have an answer for me? Darn. Sad. Yes?
The other participants, like there's some sort of paradox between decentralization where you agree that this data is going to be out there, and then mixing, like you have to kind of trust other participants in them.
Yeah, so it's back to the triangle we were talking about before. So if you decentralize something, you give up some security and you give up some scalability, which means that it's going to be a little bit more complicated, question mark. So here are some words. There are a couple adversarial models that you need to consider when we think about this. In a given mixing set, there are like maybe 3 different kinds of adversarial models we can think about. So first is the passive adversary. They're just there to collect information, and they're part of your mixing set. They don't ever mix anything, so they're just there, but they're collecting information, and so they get to see like who is sending in transactions, who is sending out transactions. They collect less information because they're not actually part of the mixer, but they're not actually part of the active mixing, but so like basic anonymity prevents those passive adversaries from learning the mapping, but they are still there. A semi-honest adversary is somebody who participates in the mixing, correctly follows the protocol, but is actively trying to decode like who else is part of this mixer. And this is problematic to anybody who is sending their coins to a mixer because it's in everyone who is sending their coins their best interest to stay anonymous. That's generally why you're sending your coins to a mixer. It's so that your coins can't can't brand you for who you are, for what you've done, what sort of transactions you've taken part in. And so the semi-honest adversary is problematic, but if you have like better cryptographic protocols, it's not always like you can sometimes like make it really difficult for them to de-anonymize the mix. The malicious adversary, on the other hand, is there generally to they're participating in the mixture, but they are not bound by the protocol specifications for some reason. Potentially that's like a problem with the protocol, but maybe their end goal is, as part of the mixer, I'm going to hope that like everybody who sends coins into this mixer, I'm going to try and like get them all to send their resulting coins to my public address, and then I can walk away with all of the coins. Does that make sense? So one person is actively trying to steal, one person is just there to learn and garner information, and one person like isn't taking part in the mixture, and so they have difficulty trying to de-anonymize. Any questions about this? The 3 adversarial models. Okay. So this is the part of the class where we talk about protocols. So let's start off with CoinJoin. One way to do what we had talked about, this decentralized mixing protocol, one example is CoinJoin, where basically the idea is we want to mix together coins. So n of us are going to come together, and we're going to spend together, put all of our 4 Bitcoin together into a transaction, and then we're going to spend it back out to 4 different addresses, which means that, that's because there were 4 of us to begin with, so we're going to spend back out to 4 addresses. And the basic idea is that if I'm A, I don't know whether or not if I'm just observing this, I don't know whether A has gone to any of these 4 addresses. Does that make sense? So whereas previously, if A had just like sent directly their Bitcoin to A prime, I would have been able to see very clearly, yes, A is now A prime, and it's owned by the same person, but now there are n of them there, where n here is 4, and so if A sends something, as an observer, I don't know whether A is A prime, B prime, C prime, or D prime. Does that make sense? Yes?
For the middle step, would it have to send the address that is A prime to the central transaction?
So generally, I think that is like auto-generated by whatever protocol. Yeah. Yeah. So unfortunately, the problems with this is that it's not secure against that passive adversary that we were talking about previously. So anybody who is part of this transaction will like anybody who is helping to facilitate this has to be part of the transaction for this to work. And so if any like one person decides, yes, I'm backing out of it, well then all N of you are like, you can't do anything about that, so you can't mix it, and you need to find another person. And then another thing is the best existing implementation for this has all of those requests go through a centralized server, which is not ideal. And it's vulnerable to traffic analysis, which is the main problem with like having all of the traffic go through one centralized server. Second of all, it's not plausibly deniable. N of n multi-signature transactions are very rare on the blockchain network, which means because how often do you know that like n people need to come together to spend like one particular thing? And so that can be problematic because just looking at a blockchain transaction analysis graph, you can again, like very quickly see, yes, this one is an N of n multi-signature transaction. That's really unusual. Let's look at the addresses it came from, etc. And then it's not DOS attack resistant, which is sort of less emphasized. So does anybody have any questions about the main idea behind CoinJoin? This is a protocol that happens sort of, it's a protocol that exists that was later like expanded upon, and we'll talk about that next. But the basic idea is here where you have n people come together independently. You just sort of provide a protocol for them to come together, decide to transact, and then get their money back. Yes?
You can discuss Schnorr.
We're not going to talk about it in this class. Yes. Okay. But Schnorr signatures are interesting, and if you have questions, you should come talk to us. Yes. Okay. Any other questions about this? Okay. So CoinShuffle builds on CoinJoin to build a better communication protocol. So that means that allowing people to come together is a little bit easier. They created this thing called Dissent, which is an accountable, anonymous group messaging protocol, so that you could find n people to come together without having to go through the centralized server, and therefore like de-anonymizing yourself even a little bit further. And it has this decryption mixnet so that it can, the words are jointly compute the input-output shuffling, but really it's just we all work together to define where the coins that have come in will go in the end. And again, this is all handled by the protocol that they've built. So yeah, if you're more interested, you can read about this on this link over here because slides will be posted. Any questions about this? CoinShuffle is really just here to show you an improvement that was made upon CoinJoin that you can go look up. Okay. Yeah, so this picture is basically saying from the left-hand side, I'm going to encrypt every time I encrypt it with another key that is specific to myself. So if I'm A, and then, yes, I'm just going to encrypt it every time I shuffle it, so nobody can see that what shuffle I've decided upon, what permutation I'm going to output, and then I do that at every node it goes through, which means at the end, whoever outputs the last like decision of where all of the original inputs will go, that last person has like a lot of control. And so the idea is to obfuscate who exactly, like, don't let the last person know that they're the last person. Yeah, does that make sense to people? Basically, every time I get to shuffle, decide who gets the inputs mapped to the outputs, every time we do that, we're just going to encrypt it so nobody knows. Yeah?
So who exactly is encrypting this?
Yeah, so each person participating, each peer, is going to encrypt the public addresses, like sort of just do an encryption layer of their own and then transfer it to the next peer. They're going to do their own encryption layer, do their shuffling, encrypt it, and then pass it on to the next person. Does that make sense? Yeah? Okay, cool. Yep, and so then it goes from one person to the next until you get to the final peer who's participating, and they output their final permutation. Okay, and then join market. So finally we get to this idea of the liquidity problem that we were talking about at the very beginning. So if you're mixing dirty coins with dirty coins, there's not as much of a point. And so how do you find the liquid Bitcoin that's not as quote-unquote dirty to mix it in with the dirty Bitcoin so that you can actually provide a service? And so the idea is to create a market for people who have clean Bitcoin, who are willing to send their Bitcoin into this market and get back slightly dirtier Bitcoin but provide this service where they can take like some sort of transaction fee. And so this is basically capitalizing on the fact that you have like pure Bitcoin. Miners will, because their Bitcoin comes directly from like a pure source, will be able to like make some money off of this. Does this make sense to people? Doesn't completely solve the problem we were talking about earlier, but is an option that is around. Okay, all right. So the final discussion question, I think we are running like out of time, so I'm just gonna skip over that one. But over to Gloria. Cool. Okay. So should I stop the recording? We don't have time. Okay, we can just cut it. So, what are some privacy-focused altcoins you guys have heard of? I'm Gloria, by the way. Zcash. Monero. I heard Monero. Bitcoin. What? All right. Great answers. We're going to be talking about two of those today, plus Dash. First one is Dash. Dash, formerly Darkcoin, is a privacy-centric coin. And I think it was one of the original privacy-centric coins, and that's why it was so exciting. And what it does is it does coin join automatically for you. And so on top of its normal layer of miners, it also has a layer of masternodes. And these masternodes are special and have privileges, and they receive 45% of the mining reward for doing special things, one of which is private send and the other one is instant send. So private send is what you think it is. It's a transaction that is more private. And so what would happen is, oh, and they also participate in governance. And what happens is the transaction will be sent to a masternode, and the masternode will take two other ones and mix them together and output the three outputs. So that's very simple. We just learned about coin join, so hopefully we all understand that. And so Jillian mentioned something about anonymity sets. So in this case, what would the anonymity set be? The number. About 2 sentences ago, I was saying how they take one transaction, then they take two other transactions, they mix them together. So what's 1 plus 2? Right, so 3, right? All right, so 3 is a pretty low number, and we want as high of an anonymity set as possible so that we get more anonymity. This masternode mixing takes some time, and generally because you only have 3 transactions mixing together, I think the standard is to do it 8 different times. And I think all transactions will go through this mixing process. And so in this case, we don't have to worry about dirty coins mixing with other dirty coins, and everyone is sus together, so it doesn't really matter. So here, everyone is kind of mixing their coins together, and there's more anonymity. That's the idea. So this is kind of the most vanilla privacy-centered altcoin. The pros are it uses coin join trustlessly. Of course, you do still have to trust the master nodes, right? So if the master node is, taking a peek at what inputs are coming in and they're mixing with, they do have access to go and see who is sending their coins in. But it does, so in this case, we would want to implement some kind of stake so that the people running the masternodes are trustworthy. So what happens is in Dash, you actually have to put up 1,000 Dash, which I think is around $150,000 right now, in order to run a masternode. I'm not really sure if there are any penalties or whatever for you de-anonymizing something, but the idea is it's not for free to run a masternode. And if you look online at, Dash, masternode, if you start looking for protocol level stuff about Dash, all you get is Dash a good investment? Masternodes, blah, 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 like investment with returns, hodl at the next level where it makes money for you. So most people see Dash as a money-making opportunity, but I think it's best for us to look at it as like the simple exercise for coin join and privacy-based altcoins. So that's cool.
We don't have the issue of plausible deniability because, like I said, we're not just mixing dirty coins, we're mixing everybody's coins. And we have the cons, it has to be secure, but we have the 1,000 Dash stake to help with that. Any questions on Dash? Great. Are we tired today? Is it the smoke? I saw this petition where we can petition to have it closed down. That's a good idea, I think. So, all right. We'll put up the link so you can sign that petition. Yeah, it's almost there, but it's like not guaranteed. But maybe.
Do you guys have a thing where they have an event where you throw rocks at the smoke?
Oh yeah, that's really effective as well. I heard that if that only takes 1,000 votes, and the smoke will disappear.
If enough people help out.
Yeah, and you can Sybil attack it too. Throw as many rocks as you want. Okay, Monero. Has anyone heard of Monero? Anyone have Monero? Fewer people. Okay, why don't you have Monero? It's great. All right, I'll tell you why. Okay, so Monero is a fork of crypto-note-based currency Bitcoin, and it has two properties. So the first is untraceability, which means that when you look at one transaction and you think of all of the possible people it could have come, well, addresses it could have come from, all of those addresses are equal probable, which means all of them are equally likely to be the actual sender of that transaction. I don't know how true that is, but you know, that's one property. The other property is unlinkability. So for any two outgoing transactions, so now, you know, broaden your imagination real quick. So you have one transaction, now imagine another one. And then so if you were to see who they go to, it's impossible to prove that they go to the same person. And just because they went, even if they do secretly go to the same person, you wouldn't be able to tell. So that's like an extra little step that isn't you know, just given to you. You actually have to work for that. Okay, so the idea of Monero is kind of like mixing, but instead of saying, oh, we're gonna mix all these transactions and give it to you, it's like we're gonna give you several different possibilities for who could have sent this transaction. So I don't really like this diagram, but I just keep it there because I think some people like it. I like to use this one. So here's a clicker question for you guys. I want you to tell me, you see this standalone water fountain. There's water flowing from the top to the bottom and then goes up. It's in this cycle. It's this circular, like a, kind of like a ring, you know? So you see this fountain. Can you tell me which bowl the water was first poured into? A, B, or C? Hands up for A. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 takers for A. What about B? 1, 2, 3, 4 takers for B. C. 1, 2, 3. Okay, sorry, I don't want to waste your time. But okay, basically, the idea is you have a 1 out of 3 chance of guessing right, right? They're all equally likely. All right, so to kind of just make it a little bit easier to understand, our best buddy Dave drew this on the whiteboard the other day, and I was like, wow, what a great explanation. This will look great on my slides. Okay, so if you really want to see how it works, you have the 3 different P's, which are your public keys. Then you have C's as well as X's. So in the end, what you're going to want to prove is from each step, you would be able to generate the next step. And so it's like a ring. This is called a ring signature, by the way. And so let's say you are able to generate one of the inputs to start that water cycle going in the fountain. But it doesn't matter which one you start at. So if you were to give someone the output, so all the X's, all of the public keys, as well as one of the C's, they would be able to generate this entire ring signature and see that all of it works out. So that is basically the validity of someone signing this transaction. You have someone's signature that is able to generate this graph, this ring signature. But you wouldn't be able to tell which one. So there's 3 public keys in here, but you could also have a lot. You could have N, right? So I nicely photoshopped a really long fountain. So basically, then you'll be able to make your anonymity set bigger, right? So ring signatures, obviously you can make a big one, a small one, whatever you want. So the whole idea is you have a ring signature. So instead of a signature coming from one person saying, yes, I sign off on this transaction, you have a ring signature that says one of these N people signed off on this. And you're able to see, given the information, like, oh yeah, this is a ring signature, and I know that it is possible because at some point someone gave in an input that was able to propagate all the way around the circle and give you a correct signature. So that's the idea behind Monero, and that it gives you the property of untraceability. So if you remember, I said untraceability is you can't trace the originator of the transaction. You don't know who sent it. And so when you are creating a transaction in Monero, you would just choose some previous set of outputs to mix your transaction with, and it could be anyone. And you can just go ahead and create a ring signature, and other people will be able to, well, you'll be able to verify that you can spend this money because your private key is going to be somewhere in that signature. And then your mix-in level, that's what the term that they use, is a number of people included, and that's equivalent to the anonymity set. Okay, I was hoping someone would like say it with me so we could like be in synchrony. But okay, but the thing is, with different fancy cryptography mechanisms that we use in these privacy-centric altcoins, is they're generally very costly to compute. So the higher your mix-in level is, the more computation is required, obviously, right? You would have to go all the way around the circle. If it was just 3, then it would be easy. If it was like 20,000, then it would be hard, right? So that also increases the size of your transaction, as well as the time it takes. The cool thing about Monero, the uncool thing before, I think prior to 2017, they didn't have hidden transaction amounts. And that was a real problem, and someone actually built a de-anonymization tool that was able to actually go and de-anonymize all of the different transactions that happened with Monero prior to 2017. And so someone was tangibly able to prove, dude, Monero sucks. But since then, they have implemented different protocols that fix these issues, and so generally now we also say, oh yeah, Monero is anonymous. And of course, anonymity is not something that you can just prove, like, it's not a Boolean, like, it's either anonymous or not, it's to a certain extent. And so one of the things that they implemented after 2017 was ring CT, or ring confidential transactions, and it's able to hide the transaction amount of your transaction so that you wouldn't be able to trace, like, say, hey, we look at one transaction of like 2.5 Bitcoin, Monero, and then here we have another one, and then you'd be able to see like vaguely which one it came from, right? So when we say homomorphic, who knows what homomorphic encryption is? Jillian knows. Good for you, Jillian. Okay, so should I explain it? So it's basically, homomorphic is just a property where when you encrypt something or you commit something A and you commit something B and then you add those together, it's this equivalent as committing A plus B. So you have that nice property of that encryption function. So it's like, you know, like matrix multiplication, it has that property where if you add 2 vectors before or after you multiply it by the matrix, it works the same way. So this is kind of the same thing. All right. And so in this case, it's still fine to hide the amount of money that you are using, because all you would have to do is the homomorphic encryption of all the inputs added together is equal to all the outputs. So as long as that's fine, everything is good, right? And we see that in other things as well. So I've talked about untraceability here. So now there's another problem. So there are these things called traceable ring signatures. So if you had 2 ring signatures that had the same private key originating from them, sometimes you can actually tell, oh yeah, they're the same thing. So that could pose a problem. Even if you can't tell exactly which one, there's, you know, other analyses, like Jillian mentioned, that you can use after linking a bunch of them together, that you could like possibly de-anonymize something. So the problem that we are trying to solve is linkability. So Monero has this property of unlinkability. So two transactions sent to the same person or associated with the same address should not be able to be detected. So how they solve this is each transaction is sent to a randomly generated one-time address derived from your public address. So I like to envision this way. I don't know if anyone watches Game of Thrones, but you're basically creating new accounts, new versions of yourself that people cannot recognize. So someone just looking at transactions wouldn't be able to say like, oh yeah, that's you too. This is probably not a good example because it still looks like him. But basically, the idea is that you're kind of putting on different hats and you're using different addresses, and that it makes it more anonymous. So the pros of Monero, it's considered a little bit more anonymous than most. The reason being is you do have a larger anonymity set, as well as other things. You know, you're making new addresses every time, etc. It's considered a little more scalable than most other other altcoins that use like heavy cryptography in their implementations, and it also obscures transaction values, which is very important for anonymity. The cons are I said it was more scalable, but it's not really that scalable. There's a large transaction size, and one other thing is like, yeah, you can have a good anonymity set, but ideally you would be able to tell like anybody is possible for this transaction input. So do we have any questions on Monero? Okay, so we're going to talk about Zcash. I personally don't know enough about Zcash because of the fact that Alessandro Chiesa is also at Berkeley, so I cannot claim to know about Zcash, but I'll try my best to explain it. Zcash uses ZK snarks, which are zero knowledge, succinct, non-interactive arguments of knowledge. So because we don't want to say that every time, we just say ZK snarks. And so the idea with Zcash is it has the maximal anonymity set. It's not just 1 out of n people could be possible. It's 1 out of everyone in the Zcash protocol is a possible sender of this transaction. And you don't have to reveal anything about the inputs or the outputs or the amount or the person of the transaction. It's zero knowledge. You don't have to know anything, which sounds like magic. And as far as I know, it's magic. But it's fully anonymous is what we would say. But again, anonymity is on like a scale. All right, so originally it was, I think, proposed as like a on top of Bitcoin idea. So in Bitcoin, if you remember, we have UTXOs where we have inputs and outputs. So you are going to prove this is the sender, this is the receiver, and this is the amount, and here's my signature. And so yeah, so you have to prove, on the right side it says, you have to prove the input hasn't been spent, the input is indeed owned by this person who is signing off on the transaction, and the sum of the inputs is equal to the sum of the outputs. In Zcash, we have this magical cloud where you don't have to know anything, but we can still prove the things on the right side of the screen. Okay. So I stole these slides from Professor Chiesa's talk at CESC 2017 last year. If you look up Alessandro Chiesa on YouTube, it's the first video that pops up, and it's a brilliant, really, really great video on anonymity in Zcash. So if you want to understand Zcash on a better level than what I'm about to tell you, definitely watch that video. Okay. So yes, he says here we have the 4 different things of information, well, 3 different information from, to, and amount, as well as the proof of ownership, not double spending, and it hasn't been spent before. What was it again? Sum of inputs equals sum of outputs. Okay, so what he says is, I am going to publish these 3 ciphertexts, and they're going to tell you, without really telling you, that it's valid. And I generate a cryptographic proof that all of this is true. And so what I want you don't have to like actually know what this says, but basically think of the Zcash protocol as I'm going to mint some money. Just I think you could pretend that there's some like magical money here, and then this is like the public stuff that happens. So I'm going to mint some money. I'm going to create magical money here. And then later when I want to spend it, I just say like, by the way, I have some magical money over here. And then you retrieve that money. And all you have to do is prove that you were indeed the person who committed that amount of money and created all that money, the magical money, before, and you're good to go. And I really don't know how to like break it down into like something simple and easy to understand more than that. But you can generally assume there's this black box where you mint the money, you mint the magic money, and then you can spend the magic money later if you provide the right amount of information. It's usually like some kind of secret, but yeah.
Do you burn the money that's spent?
That's like kind of the idea, yeah. So you could think of it as like, oh, I have these Bitcoin, and I'm gonna burn the Bitcoin for like the Zero coin or the Zcash coin, and then that's totally anonymous. And then when I try to retrieve it, there's no way for me to say that any of the magic Z coins is any more likely than the one that you like. So let's say there's like 1 million of those coins. When you pick one out of the bucket, it could be any of them. Yeah. So that's the idea of fully anonymous, is that you're involved, everyone is equal probable. So every single person in this network is equal probable. And it can be fully integrated with any consensus mechanism. It's not reliant on proof of work or anything, which is pretty cool. But the cons are it's very, very resource intensive. So it's very computationally expensive to generate a zero knowledge proof. These kinds of things don't come for free, of course. So that's one problem. Also, there's like this, maybe I'll post it on Piazza, there's this like funny video about how they did the one-time trusted setup. This type of encryption like requires one-time trusted setup, and so they generated a bunch of secrets, and that's going to be used to generate the different transactions. And so after they generate those secrets, evidently they like threw it out and destroyed the computers and did not connect it to any online source, so it's impossible for anyone to get it. They like drove out into the desert and did it, all that stuff to keep it like from ever being communicated to anybody, and they destroyed it. So hopefully if we can trust that they didn't collude, then Zcash is very secure as well. Any questions on Zcash? I don't want to go over time. So I want to talk a little bit about Mimblewimble. So story time. I think Mimblewimble is also one of those like legends in Bitcoin and blockchain history. So Satoshi Nakamoto was an anonymous person, and we very much admire him or her or they or whatever for creating Bitcoin anonymously and like generously, and you know they're like the benefactor of the crypto world, whatever. And so at some point in, I can't remember, 2016, this guy called Tom Elvis Jedusor, which is actually Lord Voldemort in French. Well, like his real name in French. You know how it's like Tom Marvolo Riddle? In French, apparently it's Tom Elvis Jedusor. And so he posted, I have this idea called Mimblewimble. And Mimblewimble is actually a spell in Harry Potter that tongue binds you, so it keeps you from talking. So that's pretty cool. So we have some Harry Potter lore in here too. And so he says, I have this idea for improving privacy, links an onion link, and then it's just this text file that talks about like different protocols. So I just had a real quick question that is leading to a meme. So true or false, a privacy solution is more scalable as well? Like inherently more scalable. There's no like black or white answer to this, but like who thinks they have an answer? Should I poll? Okay, yeah. Who thinks A is true? They're basically the same thing. All right. Who thinks it's B, true? Privacy solutions usually take up less time and space. All right. Good job, Alan. C, false. You cannot have privacy with scalability. And what about D? Some techniques require more time and space. Yeah, so I said that a bunch of times while I was talking, right? So that's the idea. I made this meme over the weekend because I felt like it. So generally, when we introduce different cryptographic techniques that we're using to enable privacy, those techniques, like I said, don't come for free. They require lots of complex computation. They increase the transaction size, which inherently means less scalability. All right. But that's not the case for everything. So for example, Mimblewimble is actually a great example of something that is both scalable and private. And so the Mimblewimble proposal, if you go and read that text file, is basically a proposal for an improvement to Bitcoin, as they said. And it's supposed to be its own coin that uses different cryptographic protocols to support a different type of transaction. And what it does is it aggregates inputs and outputs and scrambles them using homomorphic encryption so that you're not able to track things and you have to store less information. And these payments are kind of all that Mimblewimble is designed to do. So it's an even lower functionality than Bitcoin. So confidential transactions are enabled through homomorphic encryption. So like I said before with Monero, you don't have to have any addresses or amounts or whatever, and you can just take it for granted. This is magic. All you have to do is know that the inputs are equal to the outputs. There's going to be nonces that people are able to provide to prove that they know the secret that unlocks this transaction, and so you can still say that these transactions are valid, but you don't have to know anything about them. And you aggregate a bunch of inputs and outputs, a bunch of transactions. So let's say we take all the transactions that happen between this room, everybody send as much money as you want to each other, and we're going to make it all one small transaction in a neat little compact piece of data. And that's going to be small and scalable, and I can fit it in my pocket, figuratively. And so, yeah, that's how Mimblewimble works. And it's more scalable as well. So can we see how it's more private? Right? Because we're hiding the addresses, we're hiding the amounts, and we're aggregating them all together. That has less to do with privacy. But, yeah. All right? And it can also be like, I send it to Dave, Dave sends it to Mark, and then Mark sends it to Jillian. That could all be one transaction as well. And so all you have is your inputs and your outputs, and then it's one big scrambled aggregated transaction, and then we're good to go. And it's more scalable because you're aggregating all these transactions together. You have to store less information. Basically, all you have to do is prove inputs equals outputs. It simplifies the transaction model, and it makes verification easier, apparently. And if you read more about Mimblewimble and how it works, apparently you also don't have to store the entire history to verify transactions. Don't know how true that is, but you can read about it.
Is it count-based or UTXO?
UTXO. Yeah. So you have a final paper that is going to be due in the middle of Dead Week. Yeah, so Monday of Dead Week. So I guess, sorry about that, but maybe just do that in the beginning of Dead Week and then study for your... That actually makes more sense, right? And then you study for your other finals. And so the prompt is to design your own cryptocurrency or blockchain platform, or you can analyze an existing one. A couple notes: we don't want you to analyze Bitcoin or Ethereum, just because we read all about that all the time, and the chances of you coming up with something better than what we read, kind of low. No, but I'm just kidding. Like, write about whatever you want, even if it's not the prompt. If you write something, if you learn something really cool, if something that we said in lecture was really intellectually stimulating and you want to write a paper about that, we would love to read it. And don't worry about the credit. Pretty much if you turn something meaningful in, you'll get full credit. So it's not hard to pass. Just put a little bit of thought, put a little bit of work, a little bit of love into it, and we'll give you full credit. Yeah, so due date is Monday 4th, and I think you're supposed to submit a topic. Is that correct, Oscar? You're supposed to by when? Tonight. Has everyone done that? Who has done that?
It's on the attendance form.
Oh, it's in the attendance form. Ah, tonight? Wow. Ah. That's cheeky. All right. So submit your topic by tonight.
Okay, yeah.
It's the same
Yeah.
binding submission.
Sorry.
Is the submission kind of a binding submission, like or else adapted?
I think that we just want you to start. So like, if you don't turn something in, we're gonna assume you haven't started, and we're gonna be like, oh no, what happened? So just make things a little easier for us. Come up with something and just send it in as soon as you can. Yeah, we're not gonna grade it, but okay, nobody's gonna turn one in, right? Who's gonna turn one in? No, a topic. A topic. Who's gonna turn in a topic tonight? Oh, it's in the attendance.
This next slide, that's in the question.
It's in. Wait, so it's not separate? Oh, sorry. You have to come up with a topic right now. I thought you would give them more time. That's why I assumed.